Today, we finish our foundation of quantitative aptitude with a topic that is pure, guaranteed marks in the banking prelims, simplification, and its close cousin, approximation. Every prelims paper carries a block of these questions and E212, a long arithmetic expression, and your job is simply to compute its value quickly and correctly. There is no tricky concept to unravel, no word problem to decode. It is speed and accuracy, plain and direct. And that is precisely why it is so valuable. These are among the fastest, most certain marks available anywhere in the paper. If an 8 true fall, and only if an 8 true fall, you have the right order of operations, quick handling of fractions and decimals, and a set of memorized facts at your fingertips. Today, we will lock down BODMAS, the golden rule of the order of operations, sharpen fractions, decimals, and the art of approximation, and build the small mental toolkit that turns a 30-second expression into a 5-second one. Get this right, and you begin every prelims paper with a bank of easy marks. Let us master simplification. Here is our path for today. First, what simplification is and why it matters. Second, BODMAS, the order of operations. Third, handling fractions quickly. Fourth, decimals and their tricks. Fifth, the art of approximation. And sixth, the speed toolkit and common traps. Let us begin. Let us begin by understanding what this topic really is and why it deserves your careful attention despite looking so plain. Simplification means taking a long numerical expression and 8-hole, a chain of additions, subtractions, multiplications, divisions, fractions, memory brackets and powers, and 8-hole, and reducing it step by careful step to a single final value. There is no story, no unknown to find. The entire challenge is to carry out the arithmetic in the correct order, without slips, and as fast as you can. It is the most direct test of raw calculation skill in the whole paper. Why does it matter so much? Because in the banking prelims, a substantial block of questions and A212, often 10 or more and A212, is exactly this: simplify or approximate this expression. These are the questions where a prepared candidate scores quickly and moves on, banking easy marks while others labor, miss them through carelessness or slowness, and you have thrown away some of the surest points in the exam. In a test decided by a handful of marks and a ticking section of block, this block is often the difference between clearing the cutoff and just missing it. And here is the encouraging truth: unlike many topics, this one has no conceptual difficulty to overcome. You do not need a clever insight or a hard-to-spot trick. You need discipline in the order of operations, fluency with fractions and decimals, and a handful of memorized numbers. All three are pure practice and 8202 entirely within your control, and 8202, which makes simplification the most reliably improvable, high certainty scoring area in all of quant. So the takeaway: simplification is reducing a long expression to one value by pure, correctly ordered arithmetic. It forms a large, guaranteed block of the prelims, and because it needs discipline and practice rather than insight, it is the most reliably improvable source of certain marks in the paper. Everything is simplification, rests on one golden rule, and A212, the correct order of operations, and A212 captured in the word BODMAS. Get this wrong, and every answer is wrong. BODMAS tells you the sequence in which to perform operations. B is for brackets, done first. O is for M A220, often A221, or orders, meaning powers and roots. D and M are division and multiplication. A and S are addition and subtraction, done last. So you always resolve brackets first, then powers, then multiply and divide, and only then add and subtract. This is not a convention you may bend. It is the fixed grammar of arithmetic, and every correct answer depends on it. Two subtleties save you from the most common errors. First, division and multiplication sit at the same level, so you perform them from left to right as they appear, not always division before multiplication. The same is true of addition and subtraction and A212, left to right at the same level. the D before M in the word does not mean division always comes first. It means that whole pair comes before the addition-subtraction pair. Second, inside brackets, you apply BODMAS all over again. Let us see why the order is everything with a simple case. Take 2 plus 3 times 4. If you wrongly go left to right and A200 tall, 2 plus 3 is 5, times 4 is 20, in A200 tall, you get 20. But BODMAS says, multiply first, 3 times 4 is 12, plus 2 is 14. The correct answer is 14, and the difference is entirely due to order. In a real exam expression with several operations, ignoring BODMAS does not make you a little wrong and A212, it makes you completely wrong fast. Order first, arithmetic second. So the takeaway, BODMAS fixes the order and A2112, brackets, then orders or powers, then division and multiplication left to right, then addition and subtraction left to right and A2112. It is unbendable. Division and multiplication share a level as do addition and subtraction. And getting the order wrong makes the whole answer wrong. Fractions appear constantly in simplification, and being slow or shaky with them is where most time and accuracy are lost. Let us make them quick. For adding or subtracting fractions, you need a common denominator and A212, and the efficient common denominator is the LCM of the denominators. Exactly the tool we built earlier. Convert each fraction to that denominator, then add or subtract the numerators. To compute 1/2 plus 1/3, the LCM of 2 and 3 is 6, so you get 3 6 plus 2 6, which is 5 6. Do not multiply the denominators blindly and wrestle with huge numbers. Use the LCM and keep the arithmetic small. Multiplying and dividing fractions is actually easier and faster than adding them. To multiply, just multiply the tops together and the bottoms together and 8 2 and 812 and cancel common factors first to keep the numbers tiny. To divide by a fraction, flip the second fraction and multiply. 2/3 divided by 4/5 becomes 2/3 times 5/4. The single most valuable habit here is cancelling before multiplying. Spotting a common factor between a top and a bottom and dividing it out early turns a frightening product into a trivial one. The biggest overall speed gain, though, is recognizing the common fraction percentage decimal equivalents instantly, exactly as we drilled in the percentage class. When an expression contains something like 37.5% or 0.125, the fast student immediately sees 3x and 1x and works with the clean fraction. Converting messy decimals and percentages into simple fractions on site is often the key that unlocks a whole expression quickly. Fractions are not the slow part of quant. Handled well, they are the fast part. So the takeaway, add and subtract fractions using the LCM as the common denominator. Multiply tops and bottoms and A212, cancelling common factors first and A212, and divide by flipping and multiplying. And above all, convert messy decimals and percentages into their simple fraction equivalents on site for maximum speed. Decimals are the other constant companion of simplification, and a few simple habits make them quick and safe. The core skill is switching fluidly between decimals and fractions, choosing whichever is faster for the step at hand. Now, many decimals that look awkward are secretly simple fractions. 0.5 is 1/2. 0.25 is 1/4. 0.125 is 1/8. 0.333 is 1/3. When a calculation involves these, converting to the fraction is often far quicker and cleaner than multiplying decimals directly. Knowing these decimal fraction pairs by heart is as valuable here as the percentage table was earlier. When you do work with decimals directly, the one thing to guard fiercely is the decimal point and A212, the placement of it. In multiplication, the number of decimal places in the answer is the total in the numbers you multiplied. In division, you shift the point to make the divisor whole. Note, decimal errors are not arithmetic mistakes at all, but misplaced decimal points, turning an answer into 10 times too big or too small. Slow down for exactly that one moment and A200, where does the point go and A200, and you eliminate the commonest decimal error. For long or messy decimals, especially in approximation questions, do not chase pointless precision. If a value is 0.49, treat it as roughly 1/2. If it is 9.97, treat it as 10. In simplification, the answer is usually exact and you must be precise. But in the approximation block, the whole point is sensible rounding and 8/112. And knowing when precision matters and when it does not is itself a skill. Match your effort to what the question actually needs. So the takeaway, switch fluidly between decimals and their simple fraction equivalents. Guard the decimal point above all since most decimal errors are misplaced points. And round sensibly for approximation while staying exact for true simplification and 8/212, matching precision to what the question needs. Approximation is the twin of simplification, and it rewards a completely different mindset, and 8/212, one of smart laziness rather than precision. In an approximation question, the expression is deliberately messy and the answer choices are spread well apart, and you are asked for the value approximately, not exactly. This is a signal and a gift. You're being told you do not need the exact answer, only one close enough to pick the right option. Trying to compute such a question precisely is a waste of the very time the question is designed to let you save. The whole skill is to round every awkward number to a convenient nearby one before you calculate. So round boldly and early. A number like 497 becomes 500, 19.8 becomes 20, 49% becomes 1/2. Then to the now easy arithmetic with these round numbers, and you land very close to the true value and 8/200, 200, 200. Close enough because the options are far apart to identify the correct one with confidence. What would have been a grinding calculation becomes a few seconds of mental estimation. The one point of judgment is how aggressively to round, and that is guided by how close the answer options are. If the choices are far apart, round hard and fast. If two options are suspiciously close, round a little more carefully, so your estimate does not fall between them. With practice, this judgment becomes instinctive, and approximation turns into some of the fastest marks in the entire paper, and 8/212, often faster than the exact simplification questions, precisely because you are allowed to be approximate. Recognizing an approximation question and switching into rounding mode is the key move. So, the takeaway, approximation questions have messy numbers and spread out options, signaling that you should round every value to a convenient nearby one and compute quickly and 8/212. Beneath fast simplification lies a small set of memorized facts, and building this toolkit is what separates quick candidates from slow ones. Let us name what to commit to memory. First, your multiplication tables and 8/212, ideally up to 20, not just 10. So much simplification is repeated multiplication and division that instant recall of tables removes a huge amount of hesitation. Alongside them, memorize the squares up to at least 30 and the cubes up to at least 15. These appear constantly, both directly and hidden inside roots and powers, and recognizing that 612 is 25 squared or that 343 is 7 cubed saves precious seconds again and again. Second, keep at your fingertips the conversion tables we have built across these classes, the fraction to percentage equivalents, and the common decimal to fraction pairs. These are the bridges that let you switch an expression into its easiest form on sight. A student who sees 0.625 and instantly thinks 5/8 is working in a different gear from one who reaches for long multiplication. This shared toolkit is why percentage, HCF, LCM, and simplification all reinforce one another. Third, cultivate a few mental maths habits, multiplying by breaking numbers apart, using the fact that multiplying by 5 is the same as halving and multiplying by 10, and always cancelling in fractions before multiplying. None of these is difficult, but together, drilled daily, they compound into genuine speed. And speed here is not about rushing and 80-12. It is about having so much pre-computed and automatic that your mind is free to focus only on the structure of the expression, not on grinding out each small step. So, the takeaway, build a speed toolkit of memorized tables up to 2,000, squares to 30, and cubes to 15, the fraction percentage and decimal fraction equivalents, and a few mental maths habits like cancelling early and 84 to 2, so that the small steps become automatic and your mind is free for the structure of the problem. Before we finish, let us name the specific mistakes that cost marks in this easy topic, because in simplification, errors and 8200 la, not difficulty and 8200 la, are the real enemy. The first and biggest trap is ignoring or misapplying BODMAS and 8212, adding before multiplying or doing division and multiplication in the wrong order instead of left to right, because the whole answer depends on order. This single slip turns a certain mark into a certain zero. Under time pressure, the temptation is to rush left to right, resist it, and always let BODMAS govern. The order is not where you save time, it is where you must not. The second cluster of traps involves signs and decimal points. A mislead minus sign or a subtraction handled carelessly across a chain of terms flips your answer silently, and a misplaced decimal point, as we saw, makes an answer 10 or 100 times off and 80 or 2/2. And dangerously, such a wrong answer often still matches one of the trap options, so it feels right. These are not conceptual failures. They are lapses of attention, and they are entirely preventable by slowing down at exactly the sign and the decimal point. The third trap is a strategic one, spending too long on a single hard simplification instead of moving on. Because this block is meant to be fast, a question that is taking you far longer than the others is a signal to leave it and return later, not to stubbornly grind. Equally, treating an approximation question as if it needed exact computation wastes the time the question was offering you. Managing which questions to do fast, which to estimate, and which to skip is as much a part of scoring this block as the arithmetic itself. Notice how the takeaway, the traps in this easy topic are misapplying BODMAS, mishandling signs and decimal points, and mismanaging time by grinding a hard question or overcomputing an approximation, and how all are lapses of discipline, not difficulty. And all are preventable with attention and smart question selection. Let us close our whole quant foundation by turning simplification into a deliberate, mark-maximizing exam routine. First, treat this block as your opening bank of easy marks and attempt it early and calmly, because these questions are fast and certain for a prepared candidate. Clearing them first builds a cushion of marks and confidence before you reach the harder, slower problems, and it eases the pressure of the sectional timer. Go in knowing this is your territory. Second, run every question through a fixed mental checklist. Is this exact simplification or approximation? If approximation, round immediately. Then apply BODMAS strictly. Convert messy decimals and percentages to clean fractions. Cancel before multiplying, and guard the sign and the decimal point at the moments they matter. This routine, practice until automatic, is what delivers both speed and accuracy and 8212. And in this block you need both, since a fast wrong answer scores the same as a slow one, nothing. Third, and most importantly, practice daily, because this entire topic is a skill of the fingers and the reflexes, not the intellect. 10 simplification and approximation questions a day, done under a timer, will steadily drop your time per question and drive your accuracy up, and the improvement is directly visible. And remember that everything you have built across these foundation classes, an 80-1-2, the number system, HCFNLCM, percentage, ratio, and now simplification, an 80-1-2, comes together right here, in the speed and confidence with which you handle raw numbers. That fluency is the platform on which every later, harder topic will stand. So the takeaway, attempt the simplification block early as your bank of certain marks. Run each question through a fixed checklist of type, BODMAS, fractions, and careful signs. And practice daily under a timer and 8200 because this reflex level fluency with numbers is the foundation on which all of quant is built. Let us gather the whole class in one breath. Simplification reduces a long expression to one value by pure arithmetic, and 80-2, or large, guaranteed, reliably improvable block of the prelims. BODMAS fixes the order, and 82-12 brackets, orders, division and multiplication, left to right, then addition and subtraction and 8 to a 12, and it is unbendable. Handle fractions with the LCM for adding, cancel before multiplying, and convert messy decimals and percentages to clean fractions on sight. Guard the decimal point above all, since most decimal errors are simply misplaced points. Approximation means rounding boldly to nearby numbers and 8212 half. The spread out options tell you exactness is not needed. Build the speed toolkit of tables, squares, cubes, and conversions, and avoid the traps of bad order, careless signs, and poor time management. That completes our quantitative foundation and A200. Next, we build on it toward the full prelim syllabus, one idea at a time. So that is simplification